Assalamu alaikum. All of my dear students, you are most welcome in my physics class today. Here you observe that two ball. If we apply some force on the first ball, this ball gains some displacement with acceleration. And if you apply the equal amount of the force on the second one, then this ball also gains some acceleration and displacement, but the result are not same with the first experiment. Why? This phenomenon is occurred due to the difference of the mass, and this example is related with the equation and well-known equation F equal to ma. This is the relation between applied force, mass and the acceleration. If you observe another example here, there is a two ball can be possible to collide with each other in different velocity, and after the collision they can move with same direction or the opposite direction. And before collision, after collision, the momentum can be possible to equal, and this phenomenon we know conservation of momentum, and the well-known equation is m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. Dear students, you know about Bangabandhu Satellite 1. This is our pride now. And how can it is possible to place into the space? By using the rocket. And do you know how can the rocket moves? The rocket moves by using the Newton's third law, the applied force and the reacting force. This rocket use the backward pressure, and after the reaction, this is called upward thrust, the rocket moves to the space. And in my today's class, all those phenomena are, and the example are shown in my lecture by mathematically. So let us start. Dear students, if you want to perform better in mathematical part of any segment or any parts of the physics, you have to or should be confirm the equation and memorize this equation carefully. And here for the better learning of my lecture today, you have to memorize the equations F equal to ma. Is a very well known here. F force, m mass, and a is the acceleration. Please note down in your register book or notebook. Another equations, the well-known equation and a momentum conservation law, m1 u1 m2 u2 equal to m1 v1 plus m2 v2. Here m1 is the mass of the first object, m2 mass of the second object, and the u1 and v1 are respectively the initial and final velocity of the first object, u2 and v2 are respectively initial and final velocity of the second object. Another very important equations is the momentum. Of the momentum is the product of mass and velocity. M is the momentum, mass, and also the velocity. To better learning this equation, this phenomenon, if you want to perform math very neat and clean and without any mistake, you just confirm some symbol of the velocity like plus and minus when you consider the velocity as plus, when you consider the velocity as minus. Here we observe that two very equal object. One is m1 and another is the mass we consider m2. We consider the velocity of the first object is u1 and also the velocity of the second object is u2. We consider the velocity of the first object u1 is greater than the second object, so that they are collide with each other. In this case, the first object applied the force on the second object is f1, and second object applied the reaction force F2. After this collision, the first object, that's been M1, gained another velocity, that's been the velocity change is the V1, and the second one also changed its velocity, it's a V2. And for this equation, this portion is known as the before collision, and this portion the after collision, and this is the moment of the collision. And for this phenomenon, we confirm this equation. In the second case, if the velocity m1 u1, the body at rest, so that you consider that the u2 velocity of the u2 is 0, and after collision, the first object can be possible to backward and the second object move front. And what happened, and how can you confirm that which velocity is positive quantity and which velocity is negative quantity? You can choose any one velocity is positive or negative, but if you observe the before collision condition, the first object direction is the right side, towards the right side, so that the right side velocity we consider that is positive, and against this the first object, this is the negative. So we can consider the velocity of the v1 as negative. If the velocity is given is 5, let us say 5 meter per second, you write the minus 5 meter per second. At the third case, we consider these two u1 and u2 are opposite direction. After collision, the first object moves backward with velocity v, and the second object moves toward the front with v2. And in this case, at the third case, which one you consider the positive and negative? Like the second case, we consider this one is positive and this v2 u2 as a negative, because this is the opposite direction of the first object, and here also it is negative and it's positive. You can consider also the vice versa. It's depends on your consideration. If after collision these two objects make a single body and moves together, they moves with equal velocity. That's mean after collision the first object velocity is v1 and the second object velocity is v2. Both are equal and they moves with as a combined body. Then the velocity are considered as v. Both are moves with equal amount of velocity. That's mean v. So we can create a new equation or write a new equation for this phenomenon. Here v1 and v2 as written as a common v. This v is the combined body velocity. Written here velocity after being joining to. Another phenomenon we can also explain here, which is called the energy conservation law. That's mean before collision and after collision energy can be possible to conserve. That's mean energy can be possible to equal. And how? Before collision there is two objects and they are moves with some velocity, so that they have some energy. The before collision energy, that's been here in this portion ek1, which is considered half m1 e1 square, the first object kinetic energy, and the second object kinetic energy half m2 u2 square. The total kinetic energy before collision, and here we consider the after collision total kinetic energy as ek2 half m1 v1 square plus half m2 v2 square. If these two kinetic energy before collision and after collision becomes equal, as like ek1 equal to ek2, and this phenomenon is called energy conservation law. And this phenomenon also another name, this collision as known as the elastic collision. Or if the before collision total kinetic energy not equal to the total kinetic energy the after collision, in this case the energy doesn't conserve, and this collision also renamed by non-elastic collision. If these two objects create the combined body in this collision, also this velocity make a common here, and we can write this equation like this way: ek2 half m1 plus m2 v square, where v acts like a combined body velocity. Students, here I want to show you a very important step on basis of my earlier discussion. Here the two bodies of masses 5 kg and 7 kg are moving opposite to each other. Very important word, you marked it, opposite to each other, with velocities 5 meter per second and 6 meter per second. After collision the two bodies are combined together and moves with a definite direction. That means this phenomenon is on the combined body situation. On the C question we observe here, determine the final velocity of the bodies of the stem. Final velocity, which is suggests that the combined condition of the object, of the two objects or two bodies. Here the first object mass is 5 kg, so that here 5 kg, and the mass of the second object here 7 kg. Initial velocity of the first object. Initial velocity is 5 meter per second. Here the 5 meter per second, and the second object velocity is 6 meter per second. 6 meter per second. But a very important sign is the negative sign. We need to use in front of the 6 because these two objects moves in opposite direction, so that we must use the negative sign of any one velocity. We consider the velocity minus sign on the second object. Now need to find the joint velocity of the object, and which is notice that here we mark v. We know the equation of this situation. We know the well-known momentum conservation equation m1 u1 plus m2 u2 equal to m1 plus m2 common v for the combined body situation and combined body velocity. So put the value after changing the side. m1 u1 plus m2 u2, m1 plus m2. The first one has 5 u1 5 plus m2 7 minus 6 5 plus 7. After calculation we can find the result, and which is 1.42 meter per second, which is called the combined body velocity. And now for the question number D. And in our D question we observe that the collision of two bodies of the stem is elastic or inelastic or non-elastic. Analyze mathematically. And how can we judge this type of collision? If the total kinetic energy before collision and after collision become equal, this situation is called the elastic collision. And when these two kinetic energy before and after is not equal, which is called the inelastic collision. Now need to find the kinetic energy is before collision and after collision. The answer number D. Kinetic energy ek1 half m1 u1 square plus half m2 u2 square. Put the value here. Half m1 is 5 u1 5 square plus half m2 is 7 and u2 is minus 6 whole square. This is the before collision total energy, total kinetic energy. Now the after collision. Total kinetic energy ek2 equal to half m1 plus m2 common v square. Why it is made common? Because there it is a combined body velocity. Half 5 plus 7, and this v which is already determined in our question number C. We observe that the before collision kinetic and total kinetic energy is 188.5, and after collision total kinetic energy is only 12.1 joule. So that we can make a comments here, ek1 not equal to ek2. That's mean before collision total kinetic energy is not equal to the after collision total kinetic energy, and so that we can make a comments here, this collision is inelastic. Students, in my earlier introducing part, I already discussed to you about the phenomenon of the motion of the rocket, and this phenomenon also shown here by a clear picture. Here we observe that a rocket moves upward with the upward thrust, which is generated by the force from the released gas, and the momentum of the released gas is create the momentum of the rocket. And for this phenomenon we can write here the value of the force of the motion, and this force is responsible to create the motion of the rocket, and F equal to del m by del t. V, F is the applied force, that is the thrust on the rocket, is a very important symbol, del m by del t, the rate of used rate of fuel used, v constant velocity of the released gas from the rocket. If we want to judge or find out the instant acceleration at any moment, any instant, then the equation m a equal to f by m. Here f, which is already we discussed, m is the at any instant if the mass of the rocket, and acceleration at any instant. So we want to make a clear conception about these rules and this phenomenon by help of a math. Students, for better understanding or better learning, you can practice a math with me on basis of the motion of the rocket, or you you can learn also the using of the equation of the motion of the rocket. Here, the mass of the shuttle spacecraft position in the space and its fuel are 3 into 10 to the power 3 kg and 50 kg respectively. If the fuel is used at a rate of 5 kg per second, the rate of fuel used, this means this is the symbol of the value of the del m by del t, and the value of this things is 5 kg meter per second, 5 kg per second. Here, and the ejected with 150 meter per second uniform velocity. Uniform velocity, another thing is constant velocity. Here the constant velocity, already the constant velocity is the uniform velocity of the rocket. The value is of 150 meter per second. 150 meter per second. Calculate the force of the shuttle spacecraft. So that this math on basis of this equation, calculate the force of the rocket or a spacecraft. We know F equal to del m by del t, uniform V, del m by del t 5 and V is 150, that's mean 750 Newton. Very easy to solve this math. Students, now I want to discuss with you another very important things which is only observed in our atomic world, which is called one-dimensional elastic collision. That's mean the collision should be elastic. That's mean before collision and after collision total kinetic energy is conserved. That's mean total kinetic energy is equal. There is no loss of energy before collision and after collision. And in this phenomenon, the before collision relative velocity among these two objects and after collision relative velocity is very equal. That's mean the velocity is exchanged among them. So that the first segment you have to memorize, have to learn that the before collision difference of the velocity, which is called the relative velocity before collision, and difference of the after collision velocity of these two objects or two bodies, this is very called as the relative velocity of these two bodies is exactly equal. And this statement, the relative velocity by which of the two bodies approach to each other before collision, like the before collision, this portion is equal to the relative velocity by which of the two bodies go away from each other, which is such as the second portion of the collision. After this is such as the after collision, they go away from each other. And in this case, the very important equation that we need to learn for the mathematical portion, find out the velocity of the first object after collision, that's in final velocity after collision, v1, and find out the final velocity of the second object also. And I want to discuss these two equations by a short technique, and this is very large equation, so need to follow the technique to memorize these two equations. Here we put here m1 plus m2, m1 plus m2, m1 plus m2, m1 plus m2. Everywhere all are common things, m1 plus m2. Here u1, u2. These two things is very common. Now twice m, m minus m, m minus, also those things is common, but need to put the sign is 1 2. Here u2 that's been m2, here u1 has been m1, and here u1 m1 minus m2, here u2 m2 minus m1. If you follow this technique to memorize these two equations, it's very easy for you. So now we practice these two equations in a math. Students, here a math, a body of mass 2 kg moving with a velocity 3 meter per second is in elastic collision. That is very important word, is in elastic collision. When you observe this line is clearly mentioned in your stem, that's mean any hints of these things, elastic collision, then we consider this type of equations and this type of phenomenon. A body of mass is 0.5 kg at rest. That is what is the velocity of the second object after collision. That means our requirement is this equation, the second, the velocity of the second object. So we know v2 u1 plus u2 for the both plus m1 plus m2, v2 and here 2m u1 that's been m1 and u2 m2 minus m1. This is the equation for this math. Now the value, the given value, mass of the first object is 2 kg, mass of the second object is 0.5 kg, 0.5 kg. The initial velocity of the first object is 3 meter per second, u1 3 meter per second, and initial velocity of the m2 that's means second object at rest that's means 0 meter per second, and the final velocity of m2 which is our required. Here u2 is 0, so that this portion is 0, only remaining part of this equation is 2, m1 is 2, u1 is 3, m1 plus m2 2 plus 0.5 2 plus 0.5 plus 0, the final equation 4.8 meter per second. That is the answer. Very important and very easy. Dear students, in my today's class I discussed with you about Newton's second law, Newton's third law, and some of very interesting example also, and also discussed with you the energy conservation law, momentum conservation law, and very interesting things, the motion of the rocket. And side by side I discussed with you where we observed the one dimension elastic collision and how the confirm that equation of the final velocity after collision of in these equations, in this phenomenon. If you have any question, you can ask with me directly or discuss with your subject teacher also. That's all from my side. Thank you all for today. Goodbye. Allah Hafiz.